Okay, so we're going to do our one word problem, and I got this one actually directly off the homework, so this one should look very similar. Maybe the numbers are slightly different, but otherwise it should function the exact same way. It says a toy rocket is shot vertically into the air from a launch pad that's 3 feet off the ground with an initial velocity of 120 feet per second. The height in h, in feet, of the rocket above the ground at t seconds is given by this function formula. How long will it take the rocket to reach its maximum height, and what is that maximum height? So I am not an artist at all, but if there's a picture that's being represented in a word problem, I'm probably going to try to draw some sort of a picture just so in my head I can kind of visualize it. So we've got a launch pad, and it says it's 3 feet high. And off the top of this launch pad, we shoot our rocket up into the air. So when you shoot something into the air, like a rocket or an arrow, or you throw something into the air, at some point it reaches its maximum height, and then it starts to fall back down to Earth because we have things like gravity. That's what happens. So if you'll notice, this is a parabolic arc. This is a parabola, and it's turned upside down, which it should be based on our function. Because our function for this, our h of t, the height in terms of the time is negative 16t squared plus 120t plus 3. Remember that our basic form for our function is f of x equals ax squared plus bx plus c. And if a is greater than 0, we have a parabola that opens up. And if a is less than 0, we have a parabola that opens down. Well, our a in this case is negative 16. So our picture does match the general information that we have, that we should have a parabola that opens down. So none of that was information it was asked for, but that helps me to kind of grasp how this problem, which is more of a physics-y problem maybe than a mathy problem, but those are like, they hold hands a lot, physics and math does. But what exactly it's looking like in our picture, in our mind. So the first question it asks is, it says, how long will it take the rocket to reach its maximum height? And what is that maximum height? So the first question asks us how long. That's asking for a time. How long is it going to take until we hit up here? And then the second question is asking actually for the maximum height. So if we think about a parabola that's turned upside down like this, and we think about its maximum height, what would this point up here be where the maximum height happens? The vertex. That's exactly right. This is our vertex. And if you remember our vertex, and if we picture this on a Cartesian coordinate system, so there's my ground, but we can picture it like a Cartesian coordinate system. The ground would act as our x-axis. That's the amount of time, and the height is our y-axis. So that's what we're trying to find. We're trying to find the x value and the y value of our vertex. And we learned a couple of different methods for doing that. We learned we could complete the square and find the vertex that way by converting it into the other format. Or we learned our vertex formula, which was a little bit easier. And that's what I would definitely recommend. So vertex formula, anytime you use it, I would write it, is negative b over 2a, and then f of negative b over 2a. And just so we understand why we're finding both of the points, this value is going to tell us our time. How long does the rocket travel before it reaches that maximum height? This part is going to tell us what the value is of the maximum height. So just by finding the vertex, we actually find both of the parts to this question. And we actually find them in the right order, which is nice. Sometimes we don't get to find them in the right order. So first thing I'm going to do is I'm going to figure out what my A, my B, and my C are from my h of t. My A is negative 16, my B is 120, and my C is 3. Now I know C doesn't come into play anywhere. Again, that's just a little bit OCD for me. So I need to find negative B over 2A. Well, negative B would be negative 120 over 2 times my A, which is negative 16. When you have a negative over a negative, those are going to make both of those positive, so we don't have to worry about that. You take 120 divided by 32, you get 3.75. So in a little less than 4 seconds, we're going to reach our maximum height with this rocket. On Pearson, it will tell you exactly how many places to round to, just so you know. So that's half of it. Now we have to find f of the 3.5. Or 3.75, excuse me. I misspoke. So I would have negative 16 times the 3.75 squared. I'm just plugging in that 3.75 anywhere in our original function that there's a t, because that is the time. And we want to find out what is the height at that time. Now you can start right here and you can type the whole bad boy into your calculator if you so choose. I went a little, like 1 step further before I typed it all in. It does not really matter. Actually, it looks like I did all of it on my paper. One of the reasons why a lot of times I will write out all of the steps instead of just typing the first thing into my calculator is because if I move a decimal 1 space too far, if I forget that little square, if I accidentally dropped a 0 somewhere when I typed it in, I would have no idea that I did that, and then I would just have the wrong answer. If I write out some of these in-between steps, I'm doing the math in smaller bits and pieces, and so then I'm less likely to do just a massive typo error. It's totally up to you. You can check your work. You can do it in multiple steps like I did and get an answer, and then you could go back up and check to make sure that if you type that whole thing in, you still get the same answer. Whatever works for you. But when you're doing a rocket launch or throwing a ball in the air or anything like that, you have to remember that you're going to have an upside down parabola because gravity will eventually pull the item back down to Earth. And so it will usually ask you how far does it travel, how high does it go, things like that. And that all has to stem from our vertex, which is nice. We just use the vertex formula.